Right, so in this video we're going to do binary addition. So binary addition, which again we've gone over in class, like normal numbers where we're used to sort of, just escaped me for a second there, 4, say 4 plus 6, obviously equals 10. Well, in binary obviously this is a lot different because 4 and 6 are represented as completely different things. So if we represent these in a different way, and let's just move that a bit further up. So 4 plus 6 equals 10. So 4, if we do the normal 1, 2, 4, and 8. So 4 is obviously just that, nothing else. And 6 is 0 plus. So if we add these two together, a 0 and a 0 doesn't make anything. It's the same in any number system. If they're both zeros, they will make nothing. A 0 and a 1, obviously we can have a maximum of 1. That's fine in binary, so that can just be 1. However, 1 plus 1, so these here, we cannot do 1 plus 1 because it's not going to work. You can't have a 2. So logical step is to put a 1 over here. So that's what we're going to do. So 1 plus 1 carries over 1 over here, but then leaves a 0 behind. So basically 1 plus 1 equals 2, which if we look, 10 is 2. So 10 over here is actually 2. So that makes sense. 1 plus 1 equals 2, essentially. And as you can see there, so we put the 1 in because 0... So 0 plus 0 plus 1 is just 1. So 8, 2, that gives you 10. Quite straightforward. However, what happens if we get into the realms of bigger numbers or numbers that are a bit more complicated than that? So let's try a harder one, because that was a little bit too easy. So let's try something like 22 plus, we'll put 17. So we know that that's going to equal 39. So 22. 1, 2, 4, 8, 16, 32, 64, and we'll put 128 even though we don't need it for an 8-bit number. Right, so 22. What do we need for 22? Well, I need a 16, I need a 4, I need a 2. That's 22. 0, 0, 0, 0, 0. And you've always got to start with the highest number first. So in 17, can 16 go into 17? Yes, it can. So we put that in first. So 0, 0, 0. And obviously to make 17, we just need a 1. And the rest are obviously going to be zeros. Now, this works out the same, luckily. I've just realised. So you get 1, 1, 1, because 0 plus 1 is 1. 0 plus 0 is that. Carry the 1 here. And again, 32 plus 4 is 36. Plus 2 is 38. Plus 1 is 39. So it works out fine. Now, I'm actually going to pick a harder one, because that one, I realised, was a little bit too easy, still, because of how it ended up. So, this one will definitely not fail. So, 20 plus 20. Or, in fact, no, I'm going to do 16 plus 16. 15 plus 15. Yeah, 15 plus 15. Which obviously equals 30. Now, the reason I'm doing 15 plus 15 is just to make it clear on terms of how this works. So 1, 2, 4, 8, 16, 32. I'm only going to have that many this time because we don't need the rest. So 15, as we know, it's all the numbers added together beforehand. So 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, plus. Right, so we start off on the right hand side first. So 1 plus 1, we know is 1 carry, 1 carry over there and then 0 underneath. So that's that sorted. Now, we've got 3 1s here. So what we do is we treat the 1 plus 1 as normal. Well, we've got a 1 carry and we've got a 0 left. So basically now we've got a 0 plus 1, which is just 1. So when you've got 3 ones, it's carry 1 and you leave 1 behind as well. So 3 ones again, carry 1, leave 1 behind. Then carry 1, leave 1 behind. And then obviously they added together is just that. So again, let's add these up. So 16 plus 4 is 20, 8 plus 2 is 10, add them together is 30. So that does indeed equal 30. So addition's quite straightforward. Binary addition does make a lot of sense in terms of how they go together. It's literally just a case of starting from the right, adding them together, and then carrying if need be, or not carrying if if it's 3 ones, you have to carry 1 and leave 1 behind. If it's 2 ones, you carry 1 and leaves nothing behind. If it's 0 and 1, then obviously it's just 1, and 0 and 0 is just 0. So it's quite straightforward, binary addition. There's not much else to say on it, really. One thing I will note, if you ever double a number, which I'll go over in multiplication, is that you can see here, so this number is exactly the same as 15, apart from now there's a 0 at this end here. So literally it's just shifted to the left by 1, which is also known as bit shifting. So bit shifting is where you just basically move the bits up or down 1, so it can either move it that way or that way. And what you'll find is when you either timesing by 2, doubling, or dividing by 2, timesing by 2 will always move it up that way 1, and you'll add a 0 onto the end. Whereas divide by 2 will push it back this way, and will take a 0 off, so it'll actually take a 0 off the end. And that's it. One other thing to note, if we were just working in a 4-bit system for this, so say that we only could work up to 8 for whatever reason, and we have this carry where we have 1, 1, and then this carry. In a computer, if there's not enough room because we've run out of bits, this is known as an overflow error, so that's an overflow, which can obviously cause a lot of problems depending on what your system is. Now, an overflow can cause many different problems, especially if you're working with specialist equipment. So if you've got a system where you needed the number 30 but you can only count up to maximum of 15, then obviously something's going to go completely wrong. So if you're trying to measure out 30 feet on a computer and it cannot do it because it cannot physically go that high, it's only going to measure 15 and things will go wrong. So this is known as an overflow. Now, in some systems, the overflow is accounted for, and it will pop up saying that there has been an overflow error because the number can't go anywhere. What do we do? But sometimes, depending on what the calculation is, the overflow can be ignored. The overflow we'll talk about a bit more in two's complement, but this has been binary addition. If anybody needs any other help with binary addition, please let me know. But it's quite straightforward, and it should you should have questions to complete as well on top of this. So I recommend that you do the questions so I can see how you're getting on and you understand as well how the concept works.